everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation from xy plus z square equal to f of x plus y plus z by eliminating the arbitrary function f. So we are given a relation and we are asked to form a partial differential equation by eliminating this f. So what we'll do, we'll just partially differentiate it with respect to x and also with respect to y. Let's see that. Given xy plus z square equal to f of x plus y plus z, consider as equation number 1. Now let's partially differentiate it with respect to x. Partially differentiating 1 with respect to x. Okay, I'll just apply dou by dou x on both sides of 1 so that I can just escape from doing error. Okay. So you can just skip this step if you are really good at finding partial derivatives. Okay. If you apply, you won't get errors. Simply. Here we are partially differentiating with respect to x, so we'll treat y as constant. Okay, partial derivative of first term plus partial derivative of second term equal to partial derivative of f of x plus y plus z is f dash of x plus y plus z into inner derivative, that is dou by dou x of x plus y plus z. This gives us here y is treated as constant, right? So we'll write this term as y into dou by dou x of x, right? Plus partial derivative of z squared with respect to x is 2z into dou z by dou x. This equals to f dash of x plus y plus z into inner derivative, that is dou by dou x of first term plus dou by dou x of second term plus dou by dou x of third term. Many of you can just solve this easily, but I'm giving a step-by-step procedure so that everyone can understand. Okay. If you are really good at derivatives, you can just skip this step. Okay. Skip all these three. You can just do directly. Partial derivative of x with respect to x is 1 plus 2z into, since we have a notation dou z by dou x is p, we'll just replace it by notation p equal to f dash of x plus y plus z into partial derivative of x with respect to x is 1 plus partial derivative of a constant with respect to x is 0 plus partial derivative of z with respect to x dou z by dou x, right? We can just replace it by p here itself. This gives us y into 1 y plus 2zp equal to f dash of x plus y plus z into 1 plus, we'll just replace it by p since we have a notation dou z by dou x equal to p, right? Fine. Now consider it as some equation number 2. Okay. Now let's partially differentiate 1 with respect to y. Now partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of 1. Here we are partially differentiating with respect to y, so we'll treat x as constant. Here x is treated as constant. Okay. Plus partial derivative of second term. See, it's not necessary to write dou by dou x on both sides of 1. Okay. Here the partial derivative of f of x plus y plus z with respect to y is f dash of x plus y plus z into inner derivative dou by dou y of x plus y plus z. Since x is constant, we can write this x into partial derivative of y with respect to y plus partial derivative of z square with respect to y is 2z into dou z by dou y equal to f dash of x plus y plus z into partial derivative of first term plus partial derivative of second term plus partial derivative of third term. This gives us x into partial derivative of y with respect to y is 1 plus 2z into, since we have a notation dou z by dou y equal to q, right? So we can just replace partial derivative of z with respect to y by q. We get q here equal to f dash of x plus y plus z into partial derivative of a constant with respect to y is 0 plus partial derivative of y with respect to y is 1 plus partial derivative of z with respect to y. You can just write dou z by dou y, or you can write q directly. This gives us x into yx plus 2zq equal to f dash of x plus y plus z into 1 plus q, right? Consider it as some equation number 3. Now we got equation number 3, which is x plus 2zq equal to f dash of x plus y plus z into 1 plus q, right? Consider it as equation number 3. Now observe 2 and 3. We have f dash in both the equations, right? F dash of x plus y plus z, f dash of x plus y plus z. So using 2 by 3, we'll just eliminate f dash from these two equations, and that gives a partial differential equation. I mean, using 2 by 3, we'll just simplify it and then we'll get the required partial differential equation. Let's see that. Now, using 2 by 3, LHS of 2 by LHS of 3 equal to RHS of 2 by RHS of 3 where f dash gets cancelled, and this gives us y plus 2zp by x plus 2zq equal to 1 plus p by 1 plus q. Now make a cross multiplication and simplify it. Y plus 2zb into 1 plus q equal to x plus 2zq into 1 plus p, right? This gives us y into 1, y plus 2zp into 1, 2zp plus y into q, qy plus 2zp into q, 2zpq equal to x into 1, x, 2zq into 1, 2zq plus x into p, px plus 2zq into p, 2zpq, right? Here 2zpq gets cancelled, and this gives us, let's write one more step, it's okay. Now we'll write the terms that involves p and q in LHS part and the terms that does not involve p and q in RHS, okay? Here you have 2zp plus qy. Now we need to bring these two terms to LHS. You'll get minus 2zq minus px. This becomes minus px and this becomes minus 2zq. This is equal to x. Now take this y to RHS, which becomes minus y, right? Now take p common from these two terms. You'll get p times 2z minus x. See, here you're having 2z minus x. In order to have the same pattern, we'll take minus 2z common, minus q common from these two terms, so that you'll get minus q times 2z minus y. See, minus q into 2z is minus 2zq, minus into minus plus qy, right? You'll get the same thing. See, we wrote in the same pattern, 2z minus x, 2z minus y. If you want, you can write like this or just take q common. Nothing is wrong in it, okay? Fine, so this completes the problem, okay? Or we can just take p common, then we'll get 2z minus x plus q times, take q common, then you'll get y minus 2z equal to x minus y. Okay, this one or this one, which completes the problem. Therefore, p times 2z minus x plus q times y minus 2z equal to x minus y, or p times 2z minus x minus q times 2z minus y equal to x minus y is the required partial differential equation. This completes the problem. Okay. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.